Good morning, everybody. So today we are going to be starting our new unit on rational expressions and equations. And we're just going to start off by talking about what they are. So a rational expression is an algebraic function whose numerator and denominator are polynomials. So you're going to be seeing things like this. Remember, this is a rational number. So 0 over 3, any kind of fraction, is a rational number. But remember that if you flip it and you have 3 over 0, this is not a rational number. If we put this into our calculator, then we end up with something that's undefined, right? So 3 divided by 0 is undefined. So that is not a rational number. And just be willing to apply this to rational expressions in a second. So rational expressions, remember, are going to be algebraic functions whose numerator and denominator are polynomials. So something like 2x minus 3 over y. And in this case, we know that you can't have a denominator of 0. So this is where we're going to start to get our non-permissible values, where your denominator cannot be 0. So in this case, we would say the non-permissible values of this function is y cannot equal 0. X can be anything. Y can be almost anything, but y cannot be 0. Because if y was 0, you'd have 2x minus 3 over 0, and this would make it undefined. Okay, let's get started. So here's two examples of rational expressions. We have 3x minus 4, and we have x squared minus 6x minus 7 over x plus 5. And remember, you can have variables in your numerator, and you can have them in your denominator. That's fine. So when you have polynomials in your denominator, though, we're going to have a problem, because if we look at this expression here, we know that that whole thing, the entire denominator, cannot equal 0. So x plus 5 cannot equal 0, because whatever this is, when it's 0, it's going to make the whole function undefined. This one will not have any non-permissible values, but this one will have a non-permissible value, and x cannot equal negative 5. Why? Because when you plug negative 5 in here, negative 5 plus 5 equals 0. So x cannot equal negative 5. And this is just identifying non-permissible values. So for example, on this one here, this one's very easy. What's the non-permissible value here? It's 0. X cannot equal 0. Why? Because if x was 0, you'd have 7 divided by 0. And we know that anything divided by 0, so 7 divided by 0, is going to be undefined, and we're not allowed to have something that's undefined. So x can be anything but 0. On this one, we're going to take the denominator again. You take the whole thing. So x minus 2 cannot equal 0, but we need to isolate the x. So we're going to add 2 to both sides, and you'll have x cannot equal 2. And we can test this out by plugging that back in. If you had 5 over 2 minus 2, what does that become? 5 over 0. And that's undefined. So just remember that when you're writing, this is an equal sign, right? And all that you do to say cannot equal is you put a dash through it. Just like that. Okay. So here we go. We're going to do 3 practice examples here determining non-permissible values. We're going to take the denominator of this one, so 2x minus 3. Remember, you're taking the whole thing, and we say that can't equal 0. And then we isolate it. So we're going to add 3 to both sides. So 2x cannot equal 3. And then we're going to divide by 2. So we're isolating x. And that's going to cancel these out. So then x cannot equal 3 over 2. Okay. Let's try this next one. So we have x squared minus 5x plus 6 cannot equal 0. And we're going to do the same thing. We're going to find our non-permissible values. But this time I'm looking at this, and it's reminded me a lot of what we've been doing in previous lessons. It looks like a quadratic formula, and a quadratic formula I'm able to factor. So let's see if I can factor this. We're going to again say it's not equal to 0, and I'm going to use my rules, and it looks like it's going to be x minus 3, x minus 2. And I can test this, right? If you need to review how to factor, you can go back to those videos. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6, which gets me back to where I started. So we know that that factor, what we did there, is good. So here we go. X minus 3 times x minus 2 cannot equal 0. Now we have two things we can work with, right? We can set this parentheses equal to 0. So x minus 3 cannot equal 0. And we can do the same for this one. X minus 2 cannot equal 0. Because if either of these parentheses is equal to 0, the whole thing becomes equal to 0, right? It doesn't matter whether we have 0 times 27 or 27 times 0. Either way, if one of these parentheses is 0, the whole thing's going to be equal to 0. So we need to check, because we have two parentheses here, and remember, it doesn't matter what's inside of them, because they're multiplying. If one of these parentheses is 0, the whole thing's going to become 0. So we're just checking to make sure that our two parentheses, what can x not be so that they don't equal 0? And for this one, x cannot equal 3. And for this one, x cannot equal 2. Good. Okay. Determine the non-permissible value for this one. So this, hopefully you're looking at this one here and seeing that it is a perfect square. And the perfect square, if you remember, is when you have something like that, right? With the same value on these sides. And so what happens here when you multiply this out is you're going to have x squared plus 5x minus 5x minus 25. And these two terms cancel out because they're the same. So you have x squared minus 25. So I was able to look at this and see, oh, that's a perfect square. That's going to be very easy to factor. And hopefully you guys were able to do that too. But if not, you know, just spend a minute or so and factor it, and it should be pretty easy. You know that those middle terms are going to cancel out because they're not there, right? So here, x cannot equal negative 5, and here, x cannot equal 5. There we go. We've done 3 examples finding the non-permissible values. Hopefully you're feeling pretty confident with those. Let's learn about simplifying. So there's a few things that we're going to kind of remember here before we start simplifying, and that's that there's such a thing as equivalent fractions. So 1/2 is the same as 2/4, right? Why would we want to remember this? It's because we're going to be using this to cancel things out later, or to multiply, to increase it, one of the fractions so that we can add them together, because 1/2 plus 1/4 is kind of hard to add together. In order to add it together, it's a lot easier to change this 1/2 so that it has a denominator of 4. And so if you think of 1/2 as being 2/4 instead, because they're the same thing, now you can very easily add them together. That's 3/4. So this is going to come in handy, right? But it's not always going to come in handy. Like if we have 7s over s minus 2, and we remember that 2 over 2 is the same as 1, right? And we decide that we want to multiply the top and the bottom by 2, is this going to help us? Well, we'd have 14s over 2s minus 4. Did that help us? No. So you're not just going to do this just for the sake of doing it. There's going to be a strategy to determine when it's going to be useful or not, right? And that's going to be when you're trying to get rid of things for simplifying. So let's look at an example where we'll be doing something like this. Let's say that we want to make an equivalent rational expression to this with a denominator of 5x plus 2. So let's say I have 8x plus 3 over x plus 2. And I want it to be the same as this. I want it to be equal to it. But I want the denominator to be 5x plus 2. So I need this side and this side to be the same. Let's just look at what happened. What did I multiply the denominator by on this side? I multiplied it by 5. Well, what you do to the denominator, you have to do to the numerator, right? So if I had a numerator of 8x plus 3, what would I have to do to it? Multiply it by 5. Because what you do to the top, you must do to the bottom. So let's see what this would be. What's 5 times 8x? That's 40x. And what's 5 plus 3, or times 3? It's 15. And down here we have 5x plus 10. So we could say that 8x plus 3 over x plus 2 is the same. It's equivalent to 40x plus 15 over 5x plus 10. They're equivalent fractions, equivalent expressions. Let's also remember that we can simplify, right? 2/4 is the same as 1/2 and 9/27 is the same as 1/3. If you can simplify, right, reducing or dividing out numbers or going into the lowest form, you always want to do that. All right, let's do some practices here. So for those of you that have your pre-calc workbooks, these are from your pre-calc workbooks. Remember, when we're doing rational expressions, we want them in the simplest form, lowest terms. We want the numerator and denominator to have no common factors other than 1. All right, let's look at this numerator and denominator. Now, the first thing that I'm noticing is they look kind of the same, right? There's a pi, there's r, this one's r cubed and this one's r squared. And then we have 4's in both of them, but this is 4 divided by 3. So I'm just going to kind of rewrite this numerator here. I'm going to work with this numerator, and I'm going to write it out as 1/3 times 4. What's 1/3 times 4? It's 4/3. And then I'm going to keep writing pi r cubed. And down here, I'm going to leave it as 4 pi r squared. Why did I do that? Hopefully you can see why that would have been useful. What that's allowed me to do is whenever you have something that's similar on your numerator and your denominator, they cancel out. So these 4's are now gone. These pi's are now gone. This I can visualize as r cubed is r times r times r, and r squared is r times r. So when you cancel them out, what are you left with? Just one of the r's, right? And in the last section, we kind of said, well, if you have r cubed minus r squared, it's going to be r to the power of 3 minus 2, which is r to the 1. So these are, I'm just reviewing some skills here. So what happens is this whole thing is gone, and this is also gone, because it's just going to be r to the 1. So all that you're left with after you do all these cancellations is 1/3 r. Easy peasy. Might not have looked easy, but when you apply the things that we've learned before, it becomes quite easy to work with. Let's deal with this one. So we'll start with the numerator. Can we factor this numerator? Yes. X plus 1, x minus 1. Can we factor the denominator? Yes. X plus 2, x plus 1. Now we're going to apply the same understandings. Take a look at this and this. What do you see? They're the same. Well, if you have something that's the same on the numerator and the denominator, what can you do with them? What did we do when we had a 4 on top and a 4 on the bottom? We cancel them out. And the same thing applies here. You can cancel them out. And so we just simplified this equation very quickly. All we're left with now is x minus 1 over x plus 2. That is much easier to work with. Okay? Much easier to graph, much easier to plug things into. This is why you simplify. So we're going to do the same thing on the top. We're going to factor out the 2x. This is x squared minus 2x minus 15. So we're factoring out our common factor of 2x from the numerator. And then on the denominator, we're going to factor out our common factor of 4x. And when you do that, you're left with x minus 5. So again, we're going to see this and we're going to try to factor that out. So we have 2x, whoops. (2x), and then here you're going to have x minus 5, x plus 3. And then we're not going to touch the denominator. 4x, x minus 5. At this point, it becomes very easy. You have common polynomials there, so you can cancel those out. And here, 2x over 4x, we can simplify into 1 over 2. Because the x's will cancel out, and the 2 over 4 will become 1 over 2. So now we're one step away. On the numerator, all that's left is x plus 3, because 1 times x plus 3 is just x plus 3. And on the bottom, all that's left is 2. And there you go. Let's try this one here. Simplifying rational expressions with pairs of non-permissible values. So here, we have two values, two variables, w and h. So let's look at our non-permissible values. So for non-permissible values, you're going to take the denominator and you're going to set it equal to 0. So w minus 4h cannot equal 0. Now you might be looking at this going, what the heck? Let's isolate w. That means w cannot equal 4h. And this is fine, guys. What this says is, let's throw in some numbers. If w was 1, what would h not be allowed to be? If w was 1, h would not be allowed to be 4. Or sorry, vice versa, right? We cannot have these be equal to 0. So if w was 4, if w was 4, what would h not be able to be equal to? 1. Okay? And let's look at that, right? That's exactly what this says. If w was 8, what would h not be allowed to be equal to? 2. Okay? That's it. So that's all that's happening here with these non-permissible values. And so you just leave it like this. W cannot equal 4h. They're in relation to one another. That's it. Let's see if we can simplify out anything. Let's see. No, we're not going to be able to simplify this anymore. So that's fine. That's all we're going to do here. just non-permissible values. This one we're going to be able to simplify things out. And this is going to be using the additive inverse property or opposites. So let's look at first factoring this numerator. This is x plus 9, x minus 9. And down here we have 9 minus x. Now, what I'm hoping that you're able to see is x minus 9 and 9 minus x. So I'm taking this one and this one. Do they look similar? They do, right? They're basically opposites. Instead of x minus 9, it's 9 minus x, right? These are basically opposites. And these, whenever you see opposites, they're going to be equal to -1. And I'm just going to show you why that is for a second. So you know that I'm okay with this, right? I like my x values to be positive. This one, is my x value positive? No, it's negative. So if I pull out a negative sign, what is that going to leave me with? -9 plus x, right? Which if I rewrite that, I would have x minus 9 over negative x minus 9. And we just saw that when you have similar things on the top and the bottom, you can cancel them out. So this ends up being equal to -1, right? By factoring out the negative sign from this one, by factoring out the negative sign, you end up with it equaling -1. So whenever you see something that looks like an opposite, you can just apply that little rule there, which makes things very, very easy. So this one, we know is going to be equal to x plus 9 These two are going to cancel out, and all that's going to be left is a negative sign. And so you're just going to have negative x plus 9. Very easy. Let's look at this one up here and try to apply the same understandings. So first we're going to deal with the numerator. This we're going to factor out a 3. And that'll be 4 minus x. Then we'll deal with the denominator. This can be factored to x plus 5, x minus 4. Now what I'm hoping that you're able to do here is see that this and this, they're opposites. When they're opposites, they're going to cancel out, and all that you're going to be left with is a negative sign. So here, I'm going to have 3 over negative x plus 5. And that's my final answer. That's it. So it looks tricky, but it's really not. So here we go. This is the last thing that we're doing for the day. If you're on YouTube, go ahead and pause the video now and work these out. What you're trying to do is simplify the following rational expressions. And I'm going to throw in also tell me what the non-permissible values are. So give this a shot, pause the video now, and we'll see you back in a minute. Welcome back to those of you on YouTube. We're going to go through your solutions now. So if you're not ready, make sure you pause it. Let's get started. So you have x squared plus 10x plus 25 over 25 minus x squared. And the first thing that you're going to be doing is simplifying your numerator. Okay? And this is going to factor into x plus 5 times x plus 5. Then you're going to simplify your denominator. And your denominator is going to be, first thing I did was remove a negative sign. So negative, and then what's left is x squared minus 25. Then I just kept the numerator the way it was and worked one more step with the denominator. And I factored that x squared minus 25 into x plus 5, x minus 5. Then we have like terms here, which you can cancel out. And you're left with x plus 5 on the top and x minus 5 on the bottom with a negative sign out front. And there's your final answer. Here on the numerator side, we're going to factor out a -2. And so that leaves us with -2 times -3 plus m. On the denominator side, we're going to just go straight out factoring. So m plus 3 times n minus 3. The numerator in the next step is going to stay the same. The denominator is going to stay the same. But we're able to cancel m minus 3 out from both sides, and we're left with -2 over m plus 3. On this last one, we're going to factor the top. So this one can be sometimes pretty difficult to do, but you have perfect squares here, right? So 16 is 4 times 4. -9 is, well, 3 times 3, but one of them is negative, right? And there's no middle terms, right? There's no mixture of x's and y's. So we know that 4x times 4x is going to give us that 16x squared. 4x times 3y, right, the outers, is going to give us 12xy. But if you look at the inners, you have -3y times 4x, and that's going to give us -12xy. So those middle terms end up canceling each other out. Then you have -3y times 3y, which gives us that -9y squared. Factor out a 2 from the bottom, so you have 4x minus 3y, and cancel out like polynomials on the top and bottom, and you're left with your final answer, 4x plus 3y over 2. Now, a very common mistake that students make when they're solving for rational expressions in this form is with the non-permissible values. So let's go over the non-permissible values here. What students tend to do is they look at this and then they say, okay, let's set the denominator equal to 0. So x minus 5 cannot equal 0. Therefore, x cannot equal 5. And then they box this answer and they say, well, x cannot equal 5. But the issue with this is you're missing something. This is after you simplify. And your non-permissible values shouldn't come from after you simplify. They should come from your original expression. So what you should have done is had 25 minus x squared cannot be equal to 0. And then simplify. So then 25 cannot equal x squared, and therefore x cannot equal plus or minus root 25, which is plus or minus 5. So it wasn't just that x can't equal 5, but it also can't equal -5. And let's look at why that is. Well, our expression was 25 minus x squared on the bottom. And so it also can't equal -5, because when you square that, it becomes positive. That equals 0 as well, right? And if I'm plugging that x value in to my original, it's going to give me an undefined. So you have to use the original values when you're doing non-permissibles. So here, m squared minus 9 cannot equal 0. So m squared cannot equal 9, which means m cannot equal plus or minus, I'm just going to do 3. Square root of 9 is 3, right? And so it's both of these. Just because we crossed out m minus 3 doesn't mean it's no longer a non-permissible value. Remember, it's technically still there. All we did was simplify it, right? It didn't just, magically remove itself. It is part of this larger thing. We simplified it down. So in this one, m cannot equal plus or minus 3, and likewise here, 8x minus 6y cannot equal 0, which means 8x cannot equal 6y, which means x cannot equal, scroll down a little bit, 6/8 of a y, which is 3/4. There we go. Okay. And that is it for the day. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.